So let's figure out how to calculate solar altitude. We've been leading up to it, and so now is the time. What I want you to see is that there's really two parts to any solar altitude calculation. The first is you got to know where the observer is, and the second is you got to know where the subsolar point is, or the solar declination, as it sometimes is called. So let's first label the four main dates where we know where the subsolar point is. So what we're going to do is look up on the globe above, and we know that on June 22nd, the sun is directly overhead at the Tropic of Cancer. So that's June 22nd. We also know that, and that's called the June solstice, we also know that on or around December 22nd, the sun is directly overhead at the Tropic of Capricorn. So we've got June 22nd, Tropic of Cancer, December 22nd, Tropic of Capricorn. And then we also know that during the two equinoxes of March and September 22nd, or thereabouts, it varies from year to year a little bit, we have the subsolar point found above the equator. And then between those dates, it moves around. So that, say, right now we're, late March, early April, the subsolar point is actually moving up gradually between the equator and the Tropic of Cancer. And so by the time we get to June 22nd, it'll be located, the sun will be directly overhead for those folks at the Tropic of Cancer. Then it'll start moving south again, and by September 22nd, it'll be moving down over the equator, and by almost the holiday season, December 22nd, it will be located above the Tropic of Capricorn, okay? So those are the dates. Now, let's take an example of the first question. The first question asks, what is the solar altitude of Salem, Oregon on March 22nd, okay? Well, one of the things that we're just going to take as a given, and it's because we've kind of said it already in the notes, but we're going to take as a given that we know the actual latitude of Salem, Oregon. So that's 45 degrees, okay? And so what we're going to do is, okay, we know the latitude here. So basically, let's write in our little equation. We're going to have the solar altitude is 90 minus something, okay? And so let's draw in a few lines on this globe. March 22nd, where is the subsolar point at? So if you look at the diagram we just did above with the globe, we can see that the subsolar point is located on March 22nd at the equator. So we'll just draw in the equator here. And we're going to write, and that's where the subsolar point is. And then our place of interest is Salem, Oregon. So Salem, Oregon is located at 45 north. And I didn't quite get that line in the right spot, but close. So 45 is the location of interest, and 0 is the equator. So how many lines of latitude then separate the location of Salem from the subsolar point at the equator? You can see there's 45 degrees. So what our equation then is going to write in, if you go up and look way at the top again on the upper right, the solar altitude is 90 minus something, the number of degrees of latitude that separate observer from the subsolar point. So the observer is at Salem, Oregon at 45 north, and the subsolar point is at the equator, so there's 45 degrees. So what we're going to do is write in 90 minus 45 equals 45. And I'll put degrees in there too. I may forget to do that once in a while, but that's always a good idea to do. So what we're saying is that at solar noon, and these are always going to be solar noon, it's the solar altitude in Salem, Oregon, is 45 degrees. Or another way of saying it is right in the smack middle of the day when the sun is highest in the sky, or if you look due south and there's the sun, it will be 45 degrees in the sky. So if you're near March 22nd, it'll be pretty close to that too. All right, so let's so that's the answer to our first question. And with all these, and later you're going to do a worksheet where you're going to do this, you need to write in the little globe diagram as we did over on the left, where we put the 45 and the 0 there, and you need to also draw in the circle. Well, excuse me, you need to write in your calculations. So with those, we're done with question number 1. So let's go to question 2. Question 2 is, what is the solar altitude at the equator on June 22nd? All right, so here we go. So the place of interest now is the equator. Okay, so that's 0 degrees. Where is the subsolar point? That's the other thing we always have to know in these. We know the observer's at the equator, and we know the subsolar point on June 22nd. We can go up to our globe way up on top there, and we labeled that. So on June 22nd, the sun is directly overhead at the Tropic of Cancer. So let's draw that in. (23.5 degrees). And I should have probably drawn that line a little lower, but well, you know what? I'll get rid of that. See how good I am with this thing here. I'm just learning to use this, so hang in with me. Okay, we'll make that a little further down. Just a little better location for that. Let's put it down here. It's a little more like 23.5, isn't it? Okay, so there we go. So 23.5 north is the location of the subsolar point on June 22nd. Okay, so at the Tropic of Cancer, the sun is directly overhead that day, and we're interested in what the solar altitude on that same day would be at the equator, which is some 23.5 degrees away. So it's always the solar altitude is going to be found by looking at 90 minus something, right? And that something is always the number of degrees of latitude that separate our observer from the subsolar point. So if you could look way up to the upper right again, that's our little formula there. I just wrote out the words rather than the numbers. So what is the number of degrees of latitude that separate the observer at the equator from the subsolar point, which is 23.5 north of that? Well, that's 23.5 degrees. So that will equal, let's see, 66.5 degrees. Okay, so in other words, if you're at the equator and you're there on June 22nd and it's right in the middle of the day and you look straight up, you won't see the sun. You'll have to look, actually, it's going to be 23.5 degrees from straight up. You'll actually be looking north to see it a little bit, okay? So 66.5 degrees, all right? So that's pretty high in the sky, higher than it was in our earlier example of Salem on March 22nd, all right? So those are a couple of examples. I'll probably post another worksheet on this just to give you some more practice, but I think we got enough done on this one now. So hopefully that made some sense.